name is Nasser Noe. I work for Agema group of Delta Networks here in Fremont, California. Today I would be presenting the management of Agema switch through RESTconf and the REST APIs. This is generic to white box switches and any network operating system that supports RESTconf should work a similar way. So first, a bit of background. RESTconf provides you with mechanism to install and manipulate and change configuration on a switch without dependence on CLI and via XML data structure and data encoding. Allows the device to be exposed to a full set of APIs that could be programmatically managed. You can use curl, you can use Python to manage your boxes consistently across multiple devices. Reduces the deployment cost as a result and reduces OpEx since the management of your devices would be through a common interface. And it also allows you to create self-service portals if you are a service provider that wants to create self-service portals that are secure and accessible via an HTML and a web browser. So how it works is that on a switch you would have your network operating system, and the network operating system would have to support RESTful APIs, and you have to have HTTP, and in my case, because I'm running ICOS 3.2x, Light TPD would be running on the box to allow interfaces via HTTP to send and receive RESTful commands. Now you can, if you're replicating the setup, you need to make sure that the switch is running ICOS 3.2x via show version command. Make sure that the Light TPD agent is running with show process proc list. And if you like, you can modify the HTTP settings via HTTP command. In my case, I have changed the HTTP port to a different port than the default. But you don't have to do that. If you like to change the HTTP settings, you could do that. On the interface end, on the management end, you can use Open Daylight with pre-installed ODL Helium SR3, and then load the RESTconf ODL add-ons. In my case, for visibility and user interface, I'm using the Chrome Postman because it has a pretty interface that shows what is being sent and what is being received. More generally, you can use curl to use the command line so you could script what you are trying to do. Now on to the demonstration of our actual interaction via Chrome and the REST API on the box. Okay, at this point I have the switch ready to go. I have verified that HTTPD is running. I have installed Chrome browser on my laptop. I have added Postman add-on to Chrome, and I'm ready to configure the box via REST APIs. First, I need to authenticate into the box. Without authentication, I won't be able to do anything. So I use the admin credentials, and I log in, and I get an OK from that login. Now that I have a token, I can do additional commands. Let's get system information first and see what we have and what we are connecting to. And you would see that we are connecting to a 8032 switch, and the system name is Demo 1. we don't like that demo1 name, so let's change that name to demo and change that via RESTful APIs. Okay, and we'll set that, and we should get a success message once we set that. Let's get the system info again and verify that the system name has changed to demo, and you can see that the system name is changed to demo. Let's do some interface manipulation at this point in time. Let's do a get info of interface 01. And let's see what the MTU is set to on interface 01. And currently the MTU is 1518. Let's change that MTU to 1552 with REST APIs. And we'll post that, and we'll get an OK message. And now let's check the interface again and make sure that we have 1552. Okay. Now let's change it back to 1518. Let's change the MTU size back to 1518. Set that, and we should get an OK again. Let's check the VLANs again. Let's do some VLAN manipulation. Sorry, let's get the VLANs first and see what we have. At this point, you would see that we only have default VLAN 1, which is by default configured on all the ports. Now let's add VLAN 10 with the name of demo. Okay, and we get a success message. Let's check VLANs again and make sure that now we have two VLANs, one default and one demo. And we do in fact have two VLANs, VLAN 1 and VLAN 10. Let's try to get the details of VLAN 10 and see what it is, what its configurations are. And you'd see the VLAN 10 and all the interfaces and details. Let's go ahead and delete that VLAN 10 and see if we can delete it via RESTful APIs as well. And the command is delete. And we get success. Let's check VLANs again one more time and make sure that we're back to defaults. Yep, we have VLAN 1 and default. Let's do some tenancy manipulation. Let's first check and see what we have for tenants configured on the box. And you would see that the tenant list is empty. Let's create a tenant 123 with local TEP IP address of 192.168.3.1. make sure that you get tenancy creation successful. Okay, now let's check tenant 123 and get its details. Okay, you see the tenant, the VLAN, and the IP address. Now let's do some negative scenarios. Let's try to change the VLAN for this tenant to VLAN 10, but we have deleted that VLAN 10 in earlier steps. Let's do a modify and try to change the VLAN 1 to VLAN 10. At this point you should get an error because VLAN 10 does not exist. If you remember, VLAN 10 was deleted in previous steps. Let's check and see that VLAN 10 was deleted. Let's check the VLAN 10 itself. There's no such entry. Let's add VLAN 10 and update the tenant to VLAN 10 again. Okay, now it's successful, and let's now update the tenant again. Okay, update should be successful. Now let's try to delete that tenant at this point in time. And get a success message, and let's try to check the tenant 123 one more time. And at this point that should conclude our quick demo of RESTful APIs and how you can manage the box via REST APIs.